let's look at if we do have that pure iron nail, which would be pretty old school. No one sells pure iron nails anymore because they rust so easily, is why. Okay, so when they're rusting, there's a reaction going on with oxygen. Also, water is involved, and especially if it's acidic water, then that can catalyze this reaction and make it happen even faster. So you put this nail outside, and it's exposed to not just oxygen in the air, but also water. Okay, so that's going to happen a lot faster. But the basic chemical reaction is between iron and oxygen. Those react together, and we get rust. Okay, and rust is iron 3 oxide. And the formula of that is Fe2O3, and that's a solid. So this is the orange solid that we all know is rust. Most of us have seen rust, right? Okay, so there's our rust. Okay, so I had mentioned that if you know that any atom in its elemental form has an oxidation number of 0, then that's going to allow you to look at any chemical reaction and very quickly know, is this a redox reaction? I'll write it here. Okay, so 26 protons. And when I say pure elemental iron, that means it's the element itself. That means it's neutral. And that means we have 26 electrons. And so overall, the oxidation number is 0 because we've canceled out the 26 protons and the 26 electrons. And so elemental iron has an oxidation number of 0. Oxidation number of 0 is true for any atom in its elemental form. Okay, so that would be true for this iron here. What about oxygen? Oxygen here is pure oxygen in its elemental form. So once again, 0. And I know oxygen is an O, and this is a 0. Those are different. This is a number, the number 0. And so we have 0 and 0 because we have two elements that are then combining to give us a compound. We have iron and we have oxygen in a compound together. We're told here from this formula that we need 2, or it has 2 irons for every 3 oxygens. This is essentially the ratio in that compound. Okay? So that's what that is telling us. So this oxidation number is something that we can feel confident by what we know about the periodic table and properties of elements gaining electrons and losing electrons, depending on what group they're in. So that's what we fall back on when we designate oxygen here as being -2. Now we can do some algebra. And then we can know what's the oxidation number of iron. Okay, when you say, wait, what? Why do we have to do algebra? Let's talk about that. Okay, so this is a compound. This is a compound, and it is neutral. Okay, unless we put some kind of charge up somewhere, all of these are neutral. Iron, neutral. Because we haven't put any, that's all it is just iron, that one element. And we haven't put any number up there, so that's neutral. Oxygen, O2, neutral. This whole compound here, neutral. So what that means is that all of the negative charges that oxygen contributes have to cancel out the positive charges that these ions are contributing. So let's look at this. We have 2 irons for every 3 oxygens. And so we could say, all right, we don't know what this number is yet, so let's just call it X. And then let's solve for X. And there are 2 irons, or in other words, 2X. There's 2 irons that have some charge to them that we don't know yet. But we do know that those have to cancel out with the 3 oxygens, each of them having -2 charge. And if they're going to cancel out, that means that they all add up to equal 0. And this is the overall charge, 0 charge of this whole compound. And again, we know that this compound is neutral because there's no charge up here. Okay, so this is the oxidation number of iron that we're going to try to figure out. There's the oxidation number of oxygen that we did figure out by looking at the periodic table. And these values here, these just come from the formula itself. How many oxygens there are for how many irons there are. Okay. So now we can do, as I said, we can do some algebra. And so we'll multiply 3 times -2 and we get -6. And then we can add 6 to both sides. And if we add 6 to both sides, then we get 2x equals +6. Ever closer. And now we can divide both sides by 2. X equals +3. All right. So that is our oxidation number of iron in this compound. So X equals, put it like that, X equals +3. That goes with the iron. Sometimes visualizing it helps too. So let's do a little visual representation of this whole idea here. That we've got 2 of these iron ions that we just figured out are +3. We've got 2 of them. And then we have 3 of these oxygens that are -2. Okay, so if we think of them like ions in this way, +3, +3, and then again, this is a ratio of 2 to 3, and then there's -2, -2, -2. And so together these will all cancel each other out. Where these -2s, 3 of them, this is contributing overall -6 charge, and the 2 +3 charged ions are contributing +6. And then these would cancel each other out, giving us a neutral compound. So I don't know if that helps kind of seeing what's going on over here, but that is one way to depict that sometimes can be helpful. Okay. All right. Let me know if there's any questions about any of this. So here's our rusty nail. Okay. let's look at, I mentioned hydrogen peroxide, so let's look at an example of hydrogen peroxide. And, wait. Okay, I'm glad I didn't erase everything yet. Because there's two things we haven't finished here yet. First off, this isn't a balanced chemical reaction yet. So here we were just looking at what's combining with what, giving what are the oxidation numbers. But this isn't even balanced, okay? So in order to balance it, we would need a 2 here. Piece of my box. We need a 2 there, and we need a 4 here, and because over here there are now 6 oxygens, so we would need a 3 there. Okay, so now it's balanced, and then we can answer this question: what is being reduced and what is being oxidized? Okay, so let's do an assessment here. We've done our math, we've figured it out. You're like, man, I didn't know I was going to be doing math, but yes. Okay, so oxidation numbers. We figured out pure elemental iron is 0, pure elemental oxygen, 0. Iron 3 oxide, and now do you notice what I called it? Iron 3 oxide. That's because it's iron plus 3. It's not because there are 3 of them. There's not. There's 2. That is how we name it. We actually say what the oxidation number of iron is. So that's what that's about. Okay, and then the oxygen in this compound is -2. All right, so let's look at the pairings of an element on one side and then the ion on the other. So here's our iron that's going from 0 to +3 oxidation number. And then let's look at oxygen that's going 0 to -2. All right, let's look at this. Let's think about what's being oxidized, what's being reduced. And we can parse this out, separate it out, by just looking at what's happening in a theoretical sense. Like, let's just look at the iron. Let's just forget about the oxygen for now. Let's just look at the iron and see what is happening if we just looked at one of them and we saw, okay, this iron is going from oxidation number 0, so I'll put a little 0 up there, to iron +3. Okay, it's going from 0 to +3 because of electrons being lost or gained. Okay, so electrons, were they lost or were they gained here? So you have a choice here. I'm going to let you try this out. Think about this. For iron to go from 0 to +3, did it lose 3 electrons? Or did this neutral iron metal gain 3 electrons and then become iron +3? Did it lose 3 electrons and became iron +3, or did it gain 3 electrons? So did it lose or gain? Did it lose or gain electrons? you have a 50-50 chance if you're flipping a coin. Or, reasoning through it, you could think about it this way. All right, I have a neutral atom that became positive charged. So then, would the electrons be lost and then leave behind extra protons when you compare the number of protons to electrons? Or did it gain these negatively charged electrons? So hopefully that helps you reason through it and know which one is correct. Iron going from 0 to +3, did it lose electrons or did it gain electrons? So it lost, maybe I'll change that to a T, lost 3 electrons. So another way that we can show that is that the iron 0 became iron +3, and then these 3 electrons are like products. Okay, those 3 electrons were separated from the neutral atom, and then that leaves behind a positive charged ion, cation, and those 3 electrons that are now separate. All right, so, and you can also, you can look at this as charge balancing. So if you have a neutral species on this side, the other side of the chemical reaction, in this case it's a half reaction, because we're not looking at the oxygen yet, this also has to have a charge balance. The +3 here is canceled out by the -3, and so overall on the product side it's also neutral. So that could also help us know that we decided correctly. Yes, it lost electrons. So nice job. Okay. Meanwhile, O2. Okay. So now we've got O2 that is becoming oxygen 2-. So now we have these oxygen anions. And because this is O2, that means we end up with 2 of them on this side just to keep things balanced. And so what that means is because iron lost electrons, and it was oxidized, I guess we should put, this is oxidation. Oxidation. It always goes hand in hand. If one of the elements is being oxidized, the other one must be reduced, because those electrons are being lost and then they're being gained somewhere else. You never have 2 that are being simultaneously oxidized and nothing's getting reduced. There would be nowhere for those electrons to go. So they go hand in hand, and so that means our oxygen is being reduced. And so therefore it's gaining electrons. And each of these oxygen atoms gains 2 electrons, right? Because we end up with a -2. And there's 2 of them. So this gains 4, this O2 gains 4 electrons to become oxide, oxygen -2. And that is our reduction process. So this helps us looking at this whole chemical reaction, and then looking at what are the oxidation numbers of each one of those species, and then taking an even closer look, which one lost electrons, which one gained electrons, and then that allows us to know what was oxidized, what was reduced. Okay.